Here is an excellent problem on mixtures, and I would like you to watch and understand this video so that you can solve similar questions. So here we have combined mixtures with ratios, so it becomes kind of complicated. The question here is, alloy A is 1 part copper to 1 parts of tin. Alloy B is 1 part copper to 7 parts of tin. How much of alloy B should be added to 30 kg of alloy A to obtain an alloy that is 1 part copper to 5 part tin? So that's the problem. So here, if you see, there are a lot of variables involved. Now, how to do such problems? Now, since we know that we are finding a ratio between two different things, even if we stick with one and try to find how much of that quantity will be required from the ratio, we can find the other. Therefore, in this problem, we'll stick with copper and then try to solve the problem. See how we approach. Let's read the problem once again. It says, alloy A is 1 part copper to 4 parts tin. It means what? It means if there are in all 5 equal parts, then out of 5, 1 is copper, right? So 1/5 of the whole is copper. That is what it means. Alloy B is 1 part of copper to 7 parts tin. That means 1 plus 7 is 8 in all, out of which 1 is copper. So 1/8 of alloy B is actually copper. How much of the alloy B should be added to 30 kg of alloy A to obtain an alloy that is 1 part copper to 5 parts of tin? That means final product should have 1 out of 6 of copper. So that is how we can understand this question, right? So I'll try to make a table here and then see if it makes more sense. So let me draw a line and then say, well, what we'll have here is, we'll have different kinds of compounds or alloys. In this case, alloy A. So alloy A has 1 part of copper to 4 parts of tin. That means if I write C as copper, so is to 4 parts of tin T, right? I'm not using scientific symbols here. We're just making variables. Let C be coppers and T be tin, okay? So in that case, what is the fraction of copper in this? That is what we'll try to figure out. So we'll try to figure out in A, what fraction is copper. We're trying to find fraction of copper. Correct? We'll find fraction of copper in this. So we say fraction of copper in this is 1 out of 1 plus 4, right? Total is, there are 5 parts. That means 1/5 is copper in A, right? Similarly, in compound B, the ratio is 1 part copper to 7 parts of tin, right? To 7 parts of tin. So what is the ratio? It is 1 over 1 plus 7, which is 1/8, right? Now the alloy which we want should have 1 part of copper to 5 parts of tin, right? Let me call that as, let's say, I don't want to use C, right? So let me call as a final product P. So in that, we want to use 1 part of copper is to 5 parts of tin. That means out of 6, 1 is copper. So it is like 1 over 1 plus 5 is copper. That means 1/6 is copper. So from here, we say that if the product is, let's say, 10 kg, then copper will be 1/5, 1/8, 1/6. Do you understand? In that ratio. So let's now figure out what is the kg amount of alloy, right? Let's say kg of alloy. Kilogram of alloy. So we are given that we have 30 kilograms of A. Let's say 30 kilograms of A is there, in which we have to add some B. We don't know how much. So let it be X kilogram of B If I add 30 kilograms of alloy of A type and X kilograms of alloy of B type, then the product finally which we get will be 30 plus X kilograms, correct? So that is the final weight of the whole thing, right? So we get this column, which gives us weight, right, of the alloy. Now in this weight, how much kg is copper? This is what we need to figure out. How much kg is copper? So let's find out kg of copper in this. Now as we have seen here, 1/5 is copper. 1 out of 5 is copper for A. That means 1/5 of 30. That means 1 over 5 of 30. That means kg of copper here will be 6. Right? In this case, it is 1/8. 1/8 of x. So that is x over 8. Right? In this case, 1/6 of 30 plus 6. So it is 30 plus x over 6. That is, you can divide both by 6. 30 divided by 6 is 5. You can write it as 5 plus x over 6. So that much is the kilogram of copper in all the three. Now from here, as you can see, we can equate and we get an equation. This is kilogram of copper in A and B, and this is kilogram of copper in, when we mix, get in product. That means sum of these two should be same as this, correct? So that gives us our equation. Do you see that? Go through this table and try to understand. You can stop the video at this time, rewind and check, right? Understand this part, it is very critical. Now we get our equation. That is, let's equate the quantity of copper in AB, which we mix, which should be equal to the quantity of copper in the product, right? And therefore, we get our equation 6 plus x over 8 should be equal to 5 plus x over 6. You see that? So that is how we get our equation. Now we can solve this, bringing numbers on one side. 6 minus 5 equals to x over 6 minus x over 8. Now 6 minus 5 is 1, and here we can take a common denominator, which is 24. And so we get to multiply this by 4, so we get 4x minus 3x, correct? And then we can simplify it by cross multiplying, right? So from here we get 24 equals to 4x minus x, that is x. So x, which is this, kilograms of alloy B. Do you see that? It should be 24 kg. That's what we get. You get it? So the question was, how much of alloy B should be added to 30 kilogram of alloy A to obtain an alloy that is 1 part copper to 5 part tin? So the answer is 24 kilograms. So that is how we get our answer. So we need 24 kilograms of alloy B, right? So this is the way these problems can be solved. So have a good look at it. So how did we do it? We picked up one material, which was copper in our case. And we said how much of copper is there in each type of alloy. And we equated that to get our answer. I hope you appreciate it. Thank you.